Hello my dear friends, welcome to this video. In this video I'll be talking about this previous year question of IIT JAM. The question was asked in 2014. It has +2 if you answer it correctly, and it has -2/3 if you answer wrongly. We have to select the one correct option out of the given. The information is the sequence xn is a sequence of real numbers. It could be positive, negative, anything. And the information is limit n tends to infinity, xn plus 1 minus xn is equal to c. That means for a sufficiently large value of n, the difference between two successive terms is equal to c, where the c is some positive real number. Then what will happen to the sequence xn upon n? The option are it is not bounded, it is bounded but not convergent, it is converging to C, or it is converging to 0. Interesting question. At first you might find few options are correct, few are not, but we need to have a solid proof in our hand to select any one of the options. The first thing that I would like to do is just make an observation on what is given. When I see this, what strikes my head? This tells me that for a sufficiently large value of n, the difference between xn plus 1 and xn is equal to c. That means if my n is sufficiently large, my n plus 1 would be equal to xn plus 1 would be equal to xn plus c, or I would say it is very close to it. I am writing equal to, but it would be very close to it for a sufficiently large value of n, where c is some positive real number. I need to think about what happens to this sequence. Could it be bounded or not bounded? It is convergent or not? The one way of thinking is thinking of whether it is bounded or not, and that might take some more time. I have an easy way. I assume that it is convergent. If I get a contradiction, it is divergent, right? So it is not convergent. I will think about it. If it is convergent, where it is converging? Is it converging to C or it is converging to 0? These will be the two things that I will be thinking, right? So let us be assume that my xn upon n converges to L, right? So my xn upon n converges to L. So can I say my xn plus 1 upon n plus 1 also converges to L? Yeah, it is like writing a default. Now I'll be thinking about if xn upon n goes to L, the next term also goes towards L itself, right? So what I see is, I see that for a sufficiently large value, large n, what I observe is my xn plus 1 upon n plus 1 would be equal to L. Therefore, I write the L over here. Is it fine? Yeah, it is totally fine writing over there over here. So that for this L is same as 1. Why I am interested in this now? Because I know that my xn could be written as xn plus c. So xn plus 1 could be written as xn plus c divided by n plus 1. Right? What I do is I just take this denominator to other side, so it becomes n plus 1 times L is same as xn plus c. Therefore, my n plus 1 L could be written as, what I observe is, I know that my xn upon n also goes towards L. Right? So what I see, I just try to write that over here. So I'll write xn upon n. So this n is extra, right? So to balance it, I just multiply it with n plus c. Therefore, my n plus 1 L is same as n. What do you think about this circle that I'm drawing now? That is xn upon n. If my n is sufficiently large, my xn upon n should be equal to L for a sufficiently large value of n, right? And then after that, plus c as it is. Now what we do, we just distribute this L inside. So I get NL plus L is equal to NL plus C. I can cancel this too. Correct. So what I'm left with? I'm left with L equal to C. Right? So that means what? That means where the sequence is converging, that point is same as C, and the option C, that is converges to C, is the correct answer. Right? It is an interesting question. Student might be thinking, sir, we will not be able to think about it in so detail. What I will suggest is try to practice as many as possible problems. And the second thing is how I thought of this solution. I first thought of a particular example. I took C is equal to 2, then I took C is equal to 3. And roughly I just found that whatever was the sequence, it was converging to the same point that I was taking as C. So it gives me the confidence that answer is going to be C. But to be more confident and tick that in the examination, what I will make you sure is that is the absolutely the correct answer. By working on 2 or 3 examples, we cannot prove that that result is true. We can guess sometimes by working on example, yes, what could be the answer if the MCQ is there, right? But we cannot be sure about it unless we prove it. So we prove that result. I hope you understood the proof of it. If you like it, please share and subscribe to the channel, right? Thank you.